Everyone, today we are going to discuss about what is shielding effect. Okay, so normally you know that, for example, if you consider this is a nucleus of an atom and this is the outermost shell, and let's say it has only one electron in the outermost shell. Okay, so although it doesn't depend that how many electrons we have in the outermost shell, but basically this nucleus attracts the electrons towards itself, right? It attracts the electrons towards itself. So it means that the nucleus exerts the force of attraction, the attractive force, right? It exerts what? The attractive force towards itself. So, and this would be same whether we have two electrons here, whether we have three electrons here, but as it is the outermost shell, so this attractive force would be the same towards the nucleus. Okay, but this attractive force can be reduced. Okay, it can be reduced. How it can be reduced? If we introduce, for example, this is nucleus, okay, and now we're going to reduce this attractive force. So how we can reduce this? When we add more shells into the atom, right? And these shells would be the inner shells. It means that now if let's suppose we have, this is the same outermost electron, right? This is the outermost shell. This is the nucleus, all right? And it means that it shows we have two shells that have added. Okay, we have two extra shells. So these shells are inner shells as they are present inner to this outer membrane. And basically how this attractive force is reduced, it is by these inner shells that are reducing the force of attraction. So in the inner shells what we have is the electrons. Okay, for example, if we have these electrons, all right, and two here and the two here. Okay, so in this way, if you have more shells, so you have more electrons. Okay, and these electrons will reduce the force of attraction. And why this is so? This is because of the repulsion by these inner electrons. Okay, so these inner electrons, they repel. It means that they are negative. Electrons are always negative, definitely you know. So negative charge. So there are so many negative charges. So these negative charges will repel each other, right? For example, if there is an electron. Okay, let me show you a bit large image of that. Okay, so if there is an electron, okay, for example, this is a part which I'm taking. Okay, and these are the two electrons. Definitely these are negative, so it would repel. Okay, so these shells would repel. So in this way what they would do, they would shield the attractive force which is present here, okay, which the nucleus is exerting on the outermost electrons. Okay, the nucleus was exerting the you can say attractive forces, right, on this outermost shell, on this outermost electron, and these inner shells, these inner electrons, they are reducing that because of the repulsion, right? So this is how they reduce the attractive force that is present between the nucleus and the outermost shell. Okay, now what is the easy way to remember this thing is that suppose that these electrons which are present in the inner shells, they are carrying a shield with them, right? So you might have heard of the shield which the warriors use in the wars, right? The wars that used to happen in the previous centuries, right? So for example, this is a shield and this is a shield. So these electrons are carrying shield, right? So now what is happening here? This is a nucleus, and this nucleus has to attract this outermost shell towards itself, outermost electrons towards itself, right? But now here are the electrons that are present in the inner shell. They are carrying a shield with them, And what is the purpose of the shield? You know that it is to protect something, protect from something, right? So these shields are also serving the same purpose, right? So these shields, they are basically protecting this electron from the attractive force of the nucleus. Okay, so they are protecting from attraction, right? So it means that the more electrons you have, the more the shields they have, right? If there is only one shell, it means that the one electron would carry only one shield, so it wouldn't protect the outermost electrons from the attractive force of the nucleus in a better way as these two electrons are doing. So these two electrons, they are two in number, so they would have two shields. So it means that now collectively these are one, two, three shields. So it means that now the attractive forces are greatly reduced. So now if we have, for example, this is nucleus and this is the outermost shell, and then we have this is nucleus, this is the outermost shell. No, not this. We're gonna add one shell too. Okay, so for example, we have now this is the outermost shell. Okay, let us make like this. Okay, so now as in this figure you can see there is no inner shell. Inner shell is absent. So is there any shield? No, there is no shield. So it means that nucleus is now going to attract it more towards itself, right? So the shielding effect, because there is no shield, so the shielding effect is zero. All right, so the shielding effect is very much reduced. Okay, so reduced shielding effect. While in this case, what you can see, this is the outermost electrons and this is the nucleus, and this nucleus is attracting force to towards itself. Okay, and now what is happening here, we have two electrons in the inner shell. Okay, so it means that they would have two shields. So now these two shields would protect the outermost electrons from this attractive force. All right, so the more the shields, the more the electrons, the more the shields, right? The more the shields you have, and if you have more shields, so you can say you have greater shielding effect. And what is meant by the greater shielding effect? It means that now the force of attraction that is exerted by the nucleus on the outermost electron is reduced. Reduced attraction or attractive forces, you can say. Okay, reduce attractive forces. So this all thing which I've explained you with the help of sheets, it is just to memorize this topic. Okay, so well, the basic mechanism that was behind it was the repulsion from the electrons. Okay, so you can remember it, the topic of the shielding effect by the help of these shields, so that would help you a lot. Okay, now let's see the examples which are present in your book. Rather, we should discuss the trends first. Okay, so now if we take the example of a group, and if you're moving from top to bottom, what will happen? Can you make a guess? Okay, so let us understand from this thing these two examples. Okay, so beryllium, in the periodic table is present above the magnesium. So the beryllium and magnesium, they are like this in the periodic table. So beryllium belongs to the second period, magnesium belongs to the third period. Now what does it mean? Why I'm writing this second and third? It means that the beryllium would have total two shells. It is present in the second period, so it would have total two shells. So it means that, for example, this is beryllium and one shell, two shell, and as it has atomic number 4, so it means that it would have four electrons, right? And suppose, okay, I must have drawn it like here. Okay, and this is the inner one. Okay, now what you can see here is that this is the outermost shell and this is the outermost electron in it. Okay, and this is actually the nucleus, right? The nucleus is attracting force, right, on this outermost electron, but these are the electrons which are present in the inner shell that is providing a shielding effect. So there are two electrons, so two shields would be there. So as there are two shields, okay, so let us write here 2. Now let us talk about the magnesium, because we are gonna see what would be the trend in the group, right? So let's see what happens in a group if we take two examples. We have explained what is the shielding effect of the beryllium, okay? But if we move towards the magnesium, as we know that it is present in the third period, so it would have in total 3 shells. So this is the first shell, this is the second shell, and this would be the third shell. So let us draw the atoms, or sorry, electrons which are present in the shells. So here we have these electrons, okay? Now this is the electronic configuration of magnesium, that electron and the dot structure of the magnesium, right? So now here in this case, these are the outermost electrons and this is the nucleus, and in between we have 1 2 3 4 5 6 7 8 9 10. We have 10 shields, okay? How many shields? We have 10 shields. So which atom is gonna have more shielding effect? Definitely that electron, that atom that has more shields is gonna have more shielding effect, right? And what does that mean? Okay, it means that there would be more reduction in the force of attraction, okay? More reduction in force of attraction, okay? So, and actually you know that it is because of the repulsion that is exerted by these inner shells, inner electrons, right? So it means that in a group we have seen the example of two atoms, beryllium, magnesium, they were present on the top of each other, right? So now we got to know that the shielding effect, as we move from top to bottom, it increases, right? So the shielding effect in the group is that the shielding effect increases, right? So this is what we got to know. Now let's discuss what happens in a period. Okay, so what happens in period, as you move along the periodic table, along a period, so what happens? Okay, let's understand it with the help of these two examples. Now lithium and beryllium, they are present like this. Lithium belongs to the first group and the beryllium belongs to the second group, but they both are present in the second period. It means that now the lithium and beryllium, they are going to have the two electrons in them, two shells in them, sorry, okay? So this is the lithium and this is, and these are the shells, right? And this is the beryllium, it would also have the same number of the shells. So both of them, they have two shells, right? Now these are the outermost electrons and the nucleus is exerting force on them, right? And the lithium has 3 atomic number, okay? So it would have only 3, so 1 2 and 3. And beryllium has 4 atomic numbers, so 1 2 3 4, right? So this is how we would draw it. Now how many electrons are present in the inner shell? So we have 1 2, and here we have 1 2. So it means that they both have two shields, as they have 2 electrons in the inner shell. So it means that the shielding effect is same, so they would have the same shielding effect. It means that as we move along a period, so the shielding effect remains same, there's no difference, right? So that was all about the shielding effect. I hope you understand it. I hope you enjoyed the video. Thanks for watching.